Hi guys, welcome to my channel. Today we're going to be looking at a problem which involves implicit differentiation. So let's get straight into it. Find the coordinates of the stationary points of the curve with equation x cubed plus y cubed minus 3xy equals 48 and determine their nature. The first thing that we're going to do is we're going to differentiate both sides with respect to x. And this is going to give us 3x squared plus 3y squared multiplied by y dash minus 3y plus 3xy dash is equal to 0. Now we factorize to get y dash multiplied by 3y squared minus 3x is equal to 3y minus 3x squared, or y dash is equal to 3y minus 3x squared over 3y squared minus 3x, which is equal to y minus x squared over y squared minus x. Now at the stationary points, we know that y dash is equal to 0, so therefore y minus x squared is equal to 0, or y is equal to x squared. Now let's substitute this into our original equation for the curve in order to find the coordinates of the stationary points. So this is going to give us x cubed plus x squared cubed minus 3x multiplied by x squared is equal to 48, or in other words, x to the 6 minus 2x cubed minus 48 is equal to 0. So if we introduce a dummy variable z and set this equal to x cubed, we can see that this is a quadratic in z. This is going to be z squared minus 2z minus 48 is equal to 0, which factorizes nicely to z minus 8 multiplied by z plus 6 is equal to 0. Now there are two cases we must consider. When z minus 8 is equal to 0, we have that z is equal to 8, or x cubed is equal to 8, which gives us that x is equal to 2. Now our other case is that z plus 6 is equal to 0, which gives us that z is equal to minus 6, or x cubed is equal to minus 6. Now from this we get that x is equal to the cube root of negative 6, which is equivalent to the negative cube root of 6. And now a simple substitution gives us the corresponding y values. So here y is equal to 2 squared, or 4, and here y is equal to the negative cube root of 6 squared, which is also equivalent to the cube root of 36. But we're not quite done yet. Recall that the question not only asked us to find the coordinates of the stationary points, but also to determine their nature. And in order to do this, we can use the second derivative test. But in order to do this, we will need to differentiate the expression again. So from this point, we can again differentiate both sides with respect to x. So this gives us y double dash multiplied by 3y squared minus 3x plus y dash multiplied by 6y y dash minus 3 is equal to 3y dash minus 6x. But recall that we're working with stationary points, and this means that y dash is equal to 0, so we can cross out these two terms. And this gives us that y double dash is equal to negative 6x divided by 3y squared minus 3x, or negative 2x over y squared minus x. So let's start with the point 2, 4. So here, y double dash is equal to negative 4 over 16 minus 2, which is negative 4 over 14, and this is less than 0. So this means that this point must be a maximum. Now we can work with our second point, which remember was the cube root of 6 and the cube root of 36. So here, y double dash is going to be equal to 6 times the cube root of 6 over the cube root of 36 squared plus the cube root of 6. Now this is going to be equal to 6 times the cube root of 6 over the cube root of 36 squared plus the cube root of 6. And clearly, since all terms are positive, this is going to be larger than 0, which tells us that this point must be a minimum. And these are our final answers. So how did you find this question? Let me know in the comments below. If you enjoyed this video, please like and subscribe and share it to a friend to see if they can solve it too.